Okay, let's take a look at the truth table of an implication. Let's say I had this statement, P implies Q implies not P. And I want to have a truth table for this statement. So let's think of what we'll need to have in our truth table. We'll need to have P. We'll need to have Q. We'll need to have not P. And we'll need to have P implies Q. And then we'll have our final statement, P implies Q implies not P. Alright, so there are two statements here, so that means we have 2 to the 2 or 4 different possibilities. We have true, 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 false, false, true, and false, false. Not P is going to be the opposite of P. So P is true, true, false, false, so not P will be false, false, true, true. Now we want to look at the statement P implies Q. What this means is if P is true, then Q is true. And if that is true, then we have a true statement. If that is false, then we have a false statement. So if P is true, then Q is true. So we want to find out, is that true? So we'll look at our first line. If P is true, is P true? Yes. Is Q true? Yes. So if P is true, then Q is true. That is true. That is a true statement. Now we want to look at the second line. If P is true, then Q. So is P true? Yes. Is Q true? No, Q is not true. So if P is true, then Q, that is not a true statement because P is true, but Q is not. So this is false. Now we get to kind of strange ones. If P is true, well, P is not true. Well, if P is not true, it doesn't matter what Q is. We can't say that the value of P tells us anything, and this is automatically going to be true. You can prove anything from a false premise, so we're going to say that is true. Okay, so anytime you've got X implies Y, whenever X is false, then the whole statement is automatically going to be true. Alright, so now we want to look at the statement P implies Q implies not P. So whenever this is false, just as we were saying, the whole thing is true. So I can automatically say this line is true. Now, in order for the whole statement to be true, whenever P implies Q is true, whenever this part is true, then this part is also true. Whenever that happens, then the implication is true. So P implies Q is true for the rest of these. The ones for these for which not P is also true will tell us the statement is true. So when I look at this first line, P implies Q, that's true. What about not P? It's false. So that makes this statement false because P implies Q is true, but not P is false. So that makes this not true. Let's look at this one. P implies Q is true, and not P is true. So that's true. When P implies Q, not P is true. Here we have P implies Q, not P, that's also true. Okay, so that is our truth table. Okay, now let's see how we can rewrite some statements in terms of if and then. So we have any point on the straight line with equation 2y plus x minus 3 equals 0 whose x coordinate is an integer also has an integer for its y coordinate. Okay, so what we can say is if x, y is a point on the line 2y plus x minus 3 equals 0, and x is an integer, then y is an integer. So let's see why this is the case. So it's saying that any point on the straight line whose x-coordinate is an integer. So that's our background, that's our if part. It has to be a point on the line, so if it's a point on the line, and the x-coordinate has to be an integer, so x is an integer. Then it also has an integer for its y coordinate, so the conclusion is that y is an integer. The square of every odd integer is odd. Okay, so the way you would do this is you would say if x is an odd integer, then x squared is odd. So the premise, x is an odd integer, the conclusion, its square is odd. Writing these doesn't tell you whether they're true or not, you're just writing them. It is true, but okay, now let's look at this next one. So this is saying n is an integer, and if 3n plus 7 is even, then n is odd. So if n is an integer and 3n plus 7 is even, then n is odd. So we have two things that are conditions. We have to have n has to be an integer, and 3n plus 7 has to be even. Now for this next one, let C be a circle of circumference 4 pi, then the area is also 4 pi. Okay, so our premise is that we have a circle of circumference 4 pi. So if C has a circumference of 4 pi, then C has an area of 4 pi. Again, you're not asked to prove these. These could be true or false statements, but that's how you would rewrite it. The integer n to the third is even if just only if n is even, not if and only if. The integer n to the third is even only if n is even. So only if n is even. So what is our premise here? Our premise is that whenever n to the third is even, n is even. So the only if kind of turns things around. If it was the integer n to the third is even if n is even, then the premise would be n is even. But the only if kind of turns it around. And so the only if tells us that if n to the third is even, then, but it's actually even more than that. It says only if n is even. So if n to the third is even, so how would I say this? N to the third is even only if n is even. If n is even. If n to the third is even, then n is even. Does that cover all cases? Let's see. If n to the third is even, then n is even. Yeah, that covers all cases. Only if n is even, right. Okay, so let's think about what we would have here. So let's say I had I'm saying that n to the third is even only if n is even. I'm not saying that if n is even, then n to the third is even. I'm saying if I have n to the third and it's even, then n is even. So if I have n to the third equals 64, then that means that n is even. If I have n to the third is 27, that tells me nothing. It says the integer n to the third is even only if n is even. So n to the third equals 8, n to the third is even, implies n is even. I did forget one thing on this, because it says the integer n to the third, so I should have started by saying let n be an integer. And then if n to the third is even, then n is even. Also on this one, if n is an integer and 3n plus 7 is even, then n is odd. We could also say if n, or let n be an element of the integers, period. If 3n plus 7 is even, then n is odd. And then I think I had one more. So the derivative I don't remember exactly what it is. The derivative of the function f of x equals cosine x is f prime of x equals negative sine x. It's something along those lines. Okay, so the way you'd write this as an if-then statement is if f of x equals cosine x, then f prime of x equals minus sine x.